Okay, so up until now, we've kind of been looking at counting possible combinations. Well, now we're going to start using that foundation to start calculating actual probabilities. So I'm just going to give you a generic example, and then we're actually just going to talk about the complement. We have a few different ways that we can calculate probabilities with the complement addition law, the multiplication law, which is sometimes called the multiplicative law. And then we're going to later talk about conditional probabilities, joint, marginal, and some other ideas. So to calculate the probability of an event, we sum the probabilities of the sample points in the event, right? We already know that. So for example, what is the probability of getting one head when tossing two fair coins, right? We've already seen this example. Here are the possible outcomes, right, which are the sample points that make up the sample space. So we could look at this, right? We're looking at getting one head out of two when we flip the coin twice. So here is an opportunity to get one head, and then here's another. So because there are four possible outcomes, all with equal probability, they each are assigned a quarter, right, in terms of probability, 0.25, 25%, right? And then we can add these two together, right, because we have here's one possible outcome and here's another possible outcome. They each have 0.25 probability, 25% chance of happening. So we'd add those together and say that there's a 50% chance of getting one head when tossing two fair coins. So let's say, what if we're interested in looking at not getting heads when we flip the coins? So the complement of A is equal to the event consisting of all the sample points that are not in A. So basically, whatever you're interested in finding, you just subtract the complement from 1 to get the actual probability. So I know this is kind of confusing, but this is actually a very simple concept. So this might be event A, right? Whatever that is. The complement would be not A, right? Which is AC, the complement of A. Different ways of writing it. So it's everything in your possible sample space that is not A. So let's look at an example. So what is the probability of not getting a heads on two fair coin tosses? So the complement would be 1 minus the probability of it happening. We already calculated in the last slide the probability of it happening, right, which is 0.5. So we can just plug in our equation, right? What's the probability of not getting a head? It's 1 minus the probability of getting heads. So 1 minus 0.5 is 0.5. So you might be wondering, Kristen, why wouldn't you just calculate the probability of getting tails, right? Why wouldn't you do something else like that? It's so much easier. Well, this example is very simple, but let's look at this diagram. What if I said, hey, calculate the area of the blue space? I don't know about you, but I wouldn't know how to calculate, these weird curves around the circle. What would make more sense is to calculate the area of the entire rectangle and then calculate the area of the circle and just subtract the area of the circle from the area of the rectangle, and that would give you all the blue space. That's basically the same concept of what we're doing here. I just gave you a really easy example right here, but sometimes these examples aren't going to be as easy, so it makes sense to actually subtract the probability of an event, something that maybe you already know, from 1 to figure out the probability of it not happening or probability of the complement something else. So I think this example, in terms of thinking about it in terms of area, makes sense to see that why sometimes this makes sense to do.